Welcome to BSc Statistics students. In this lesson, I explain derivation of probability density function of Fischer T distribution. So I have explained student T distribution. Now I explain Fischer T distribution, derivation of probability density function, PDF of Fischer T distribution. So first of all, I consider Fischer T statistic. What is Fischer T statistic? It is defined as T is equal to chi divided by square root of chi square by n. That is the ratio of standard normal variate and square root of chi square variate divides its degrees of freedom. That is Fischer T statistic. So if you consider this in which xi follows xi which follows n01, that is standard normal distribution. Therefore, f of xi, that is probability density function of xi, is going to be explained as, it is going to be considered as 1 by root 2 pi, the formula of PDF of standard normal distribution, 1 by root 2 pi e power minus z square by 2. Here it is xi square by 2, xi square by 2. And the limits are minus infinity, less than xi, less than infinity, less than xi, less than infinity. Next one, the chi square. Here this chi square follows a chi square distribution with n degrees of freedom. Hence, PDF of chi square is f of chi square is equal to 1 by 2 power n by 2 gamma of n by 2. This is known as gamma of n by 2 e power minus chi square by 2 and chi square whole power n by 2 minus 1, for which the limits are 0 less than or equal to chi square less than infinity. That is 0 to infinity. Chi square limits are 0 to infinity. So now we have to calculate the distribution of t. T is equal to xi by square root of chi square by n. That is what we have to calculate. The probability density function of t we have to calculate, for which we are using two variable Jacobian transformation method. Two variable Jacobian transformation method. What is that? You have to consider another variable. For example, t is equal to, now it is xi divided by square root of chi square by n is one variable. Then you have to consider another variable, that is, let it be u is equal to chi square. U is equal to chi square. Usually you consider the variable in the denominator. Variable in the denominator. You can consider chi square by n also. Okay, like that. So u is equal to chi square I have considered, and now you calculate xi and chi square in terms of t and u. That is what you have to consider transformations. First of all, transformations. How to calculate xi in terms of chi square and t, xi in terms of t and u, and chi square in terms of t and u. So both xi and chi square are to be calculated in terms of t and u. That is called, which are called transformations. So xi is equal to, first of all, I am calculating xi is equal to t into square root of chi square by n. But chi square, it is going to be considered also to be transformed. But whereas chi square is equal to u, simply you can write chi square is equal to u. So you replace this u in this formula, so that t into square root of u by n, that is xi is equal to t into square root of u by n, and chi square is equal to u. So now you see both are transformed. These are called transformed variables. So xi and chi square are expressed in terms of t and u, right? So now we have to calculate Jacobian two variable transformation Jacobian value, first of all, in which I am calculating now Jacobian j. What is the formula of the Jacobian j? Jacobian j, it is going to be calculated by dou xi by dou t. Similarly, xi is going to be differentiated with respect to u, dou xi by dou u. Similarly, dou chi square by dou t, dou chi square by dou u. This is the formula of the Jacobian two variable transformation, in which the Jacobian formula is this. So the Jacobian is going to be calculated by dou xi. by dou t. The xi is to be differentiated with respect to t. That is root u by n is a constant multiplied by t differentiation is 1. That is root u by n. And xi is to be differentiated with respect to u. That is t by root n is constant. T by root n is constant, and root u differentiation is 1 by 2 root u. Leave it and get to that. Chi square is equal to u with respect to differentiation with respect to t, hence it is 0. And chi square with respect to u, chi square differentiate with respect to u differentiation with respect to u is 1. So now the final value is you multiply root u by n multiplied by 1 minus 0 into this, therefore 0. So root u by n is Jacobian. So therefore you have to calculate modulus of Jacobian. Modulus of Jacobian is again root u by n, because u is chi square, because I show you, yeah, u is equal to chi square. Therefore chi square limits are 0 to infinity, therefore u limits are 0 to infinity. Therefore modulus of Jacobian is root u by n. This is u and divided by n. That is what the modulus of Jacobian. Now by using two variable transformation method, first of all we calculate joint PDF, the joint probability density function of t and u. So we calculate for new variables t and u, the joint density function you have to calculate first. The joint PDF of t and u, it is going to be calculated by f of t comma u, for the variables tu, it is tu, is not v, it is u. It's going to be calculated by, the formula is f, the variables chi square, and by using the variables chi square and xi. So therefore it is f of xi and chi square. Xi is x, first variable of xi chi square multiplied by joint, that is multiplied by Jacobian. The joint PDF of xi and chi square multiplied by Jacobian, that is known variables. These are the distributions also we have written. We have considered xi and chi square here in the formula, xi and chi square in the formula of the t, which are known variables, for which the PDFs we have written f of xi, f of chi square. Always you remember xi and chi square are known variables, for example x and y. So xi and chi square are known variables, and for unknown variables, for example t is only unknown variable, but of course you have considered. And for t and u, the joint density function of t and u can be expressed as, by using the two variable transformation method, xi and chi square, joint PDF of xi and chi square multiplied by modulus of Jacobian. So because these are independent, xi and chi square are independent, then hence f xi we can write as f of x into f of y, if x and y are independent. Therefore f xi of xi and f chi square of chi square multiplied by Jacobian j. Now what you have to write, this step is very crucial. What we have to write for xi and chi square, you have to write transformed variables, transformations. Xi is equal to t into root u by n, chi square is equal to u. You write down the transformed variables, that is t into square root of u by n, that is transformations. Xi is equal to t into square root of u by n, and multiplied by f chi square. F chi square is equal to u multiplied by Jacobian. Jacobian is square root of u by n, modulus of Jacobian, u by n, which means now this is nothing but transformed method, that is two variable transformation method. So you see here the variables are transformed, xi is transformed, chi square is transformed. Okay, so these are called transformations. Now this is, now in the place of the PDF of xi, you have to use this particular function, that is this particular value of xi, the transformation, and the value of chi square, the transformation. These are, this is PDF of chi square, this is PDF of xi, that is the indication of f xi of t into root u by n, f chi square of u. So this is PDF of xi, this is PDF of chi square. So in the PDF of xi, what is PDF of xi? The PDF of xi is 1 by root 2 pi e power minus xi square by 2. So in which we have to transform this 1 by root 2 pi into e power minus xi square, that is xi is t into root u by n whole square, that is t square into u divided by n multiplied by 2. So 2n. So square of this, okay, and multiplied by what is transformation of chi square? That is u. So therefore, PDF of chi square is 1 by 2 power n by 2 gamma of n by 2 and e power minus chi square by 2. Chi square is u, that is minus u by 2, and chi square power n by 2 minus 1, that is u power n by 2 minus 1. Multiplied by Jacobian, that is root u by n, modulus of Jacobian. This is what the joint PDF. I simplify joint PDF of t and u, that is f of t comma u. Okay, and this is what I write. I simplify and write these values, and so that we can easily do the problem. So 1 by root 2 pi constant, 2 power n by 2 is another constant, and gamma of n by 2 another constant, multiplied by what else here, root n. I'm considering root n. Root n is another constant. Okay, 1 by root 2 pi, 2 power n by 2, gamma n by 2, root n constant in the denominator. And now you see this is e power minus t square by 2 into u by n, and this is e power minus u by 2. Here also e power minus u by 2. The term, so I am taking common e power minus u by 2 multiplied by, here it is 1, here in this term it is in the power, it is 1, plus this is t square by n, t square by n, and u by 2 we have taken a common, and multiplied by, and u power, now powers of u I see, I check out, u power, this is n by 2, and this is u power 1 by 2, that is n by 2 plus 1 by 2, I am taking as n plus 1 by 2. This is n by 2, this is u power 1 by 2, root u, hence it is u power 1 by 2, minus 1, n plus 1 by 2 minus 1, n plus 1 by 2 minus 1. Let us consider this is joint probability density function of t and u, right? This is what we have calculated. Now it is required to calculate f of t. That is our question. That is our problem. What is the problem? You have to derive the density function of t. The density function of t, that is PDF of t. So we have to derive it. So for which f of t, the formula is f of t is equal to integral. It is going to be calculated by the joint density function. If you integrate with respect to u, you will get PDF of t, marginal density function. The marginal is going to be calculated with the help of the joint. If you integrate joint with respect to u, you will get joint marginal of t, marginal of t. So that is the formula I'm using here. So for which integral, this one, this is joint. So that is integral. What are the limits of u? U is equal to chi square. Chi square limits are 0 to infinity. Therefore, limits of u are 0 to infinity. That is 0 to infinity. It is 1 by root 2 pi. All the constants I write at the, in the next step outside, I take outside, and gamma n by 2 and root n multiplied by e power, I write, okay, minus u by 2 into 1 plus t square by n multiplied by u power n plus 1 by 2 minus 1 and du. This is what the function. Now I go to the next page and I do the differentiation with respect to u. That is what I do, the differentiation with respect to u. Now you see, that is I'm calculating f of t. Just now I have shown the what is the value. How do you get the f of t? F of t is going to be obtained by by integrating f of tu with respect to u. That is joint with respect to u. So therefore, where I consider all the, I have taken all the constants outside. First of all, 1 by root 2 pi and 2 power n by 2 and gamma n by 2 and root n. All the constant I have taken outside first of all, and multiplied by, for remaining values, integral 0 to infinity. I will apply now this integration with gamma integral with two parameters. Gamma integral with two parameters. That is integral 0 to infinity e power I write as e power minus 1 by 2 multiplied by 1 plus t square by n multiplied by u minus u by 2. I take u here. I write u here. E power, this entire thing is, for example, you consider a, and u power n plus 1 by 2 minus 1 du. That is what the terms you have, in which you consider this is a, this is a, and this is b, this is b. This is what you consider as b. This is a and this is b. A is 1 by 2 into 1 plus t square by n. B is n plus 1 by 2. Now I write the formula integral 0 to infinity e power minus ax x power lambda minus 1 dx is equal to gamma of lambda by a power lambda. This is what the gamma integral. What is this? This is called gamma integral. Now we apply this. If you apply this, this integration becomes e power minus ax x power lambda minus 1. Here we have considered b. Consider lambda in this particular formula. You consider lambda. Okay. Lambda is n plus 1 by 2. This is a, 2 parameters. This is gamma integral with 2 parameters. So in the place of a, again I explain, in the place of a, 1 by 2 into 1 plus t square by n you consider, and in the place of lambda you consider n plus 1 by 2. So therefore, by considering that, your integration, our values becomes 1 by root 2 pi and 2 power n by 2 gamma of n by 2 root n, the constants as usual, and gamma of lambda. Gamma of lambda, what is lambda? N plus 1 by 2. Gamma of n plus 1 by 2 divided by a power lambda. A is 1 by 2 into 1 plus t square by n whole power lambda. A power lambda. A power lambda. This is what the formula. A power lambda is n plus 1 by 2. This is what the result of this particular integral. Integral 0 to infinity e power minus ax x power lambda minus 1 dx can be expressed as gamma of lambda by a power lambda. Now you see, you can see what are the terms are going to be cancelled. 2 power n by 2. This is 2 power n by 2. It is going to be cancelled. 2 power n by 2 and 2 power 1 by 2. 2 power 1 by 2 in the denominator and denominator. 2 power 1 by 2 is root 2. So root 2 also getting cancelled. Okay. Root pi here, gamma n by 2 here, root n here. Now you write that next term is equivalent to be 1 by root pi gamma n by 2 and root n, okay, multiplied by gamma of n plus 1 by 2, n plus 1 by 2 divided by 1 plus t square by n whole power n plus 1 by 2. Okay. So now I write it is equivalent to be, now I write this one as I simplify further, 1 divided by root pi I am considering as it's the value of gamma 1 by 2 and this is gamma n by 2 divided by, I consider gamma n plus 1 by 2 in the denominator. So it will be here and I write gamma n by 2 plus 1 by 2. That is gamma n by 2 plus 1 by 2 and multiplied by root n. Okay. This is gamma 1 by 2. This is gamma n by 2. Gamma n by 2 plus 1 by 2 I have taken here and multiplied by 1 divided by 1 plus t square by n whole power n plus 1 by 2. This is what the value. Now further, you see here, I write here one more important formula. It is beta of m comma n, the formula is equal to gamma m gamma n divided by gamma of m plus n. This is what the formula of beta m mn. By applying this formula, 1 divided by root n and this is beta gamma 1 by 2 gamma n by 2 a b divided by a plus b, or whatever you consider. N by 2 is a, it is b, a plus b, or m n m plus n. So therefore you can write it as gamma n divided by gamma m plus n. So therefore you can write as beta 1 by 2 n by 2. This is the formula, 1 by root n beta 1 by 2 n by 2 into 1 by 1 plus t square by n the whole power n plus 1 by 2. This is what the formula. Hope you understand. This is f of t, where limits of t minus infinity less than infinity. This is the formula of the probability density function of t distribution, Fischer t distribution. 1 by root n beta 1 by 2 n by 2, 1 by 1 plus t square by n whole power n plus 1 by 2. The limits of t are minus infinity less than infinity. This is what the probability density function of Fischer T. You compare it with student T distribution. Student T distribution is 1 by root n minus 1, beta 1 by 2, n minus 1 by 2, 1 by 1 plus t square by n minus 1 whole power n minus 1 plus 1 by 2. That is the parameter with n minus 1. That is only one case of Fischer T. In the place of n, if you consider n minus 1, the degrees of freedom, then it is only the formula for n minus 1 degrees of freedom. Whereas Fischer T distribution is generalized distribution. Generalized, it takes for all the values of n, it is true. That is 1 by root n beta 1 by 2 n by 2 and 1 by 1 plus t square by n whole power n plus 1 by 2. This is the formula of Fischer T distribution. PDF of Fischer T distribution, probability density function. So this is the derivation of PDF of, that is probability density function of Fischer T distribution. Thank you.